Yeah. Hello, everybody. I just will show my face for a second. My name is Mario, and I am representing University of Tartu Laboratory Animal Center. And soon Anton will present our latest data. But in general, during the last 6 years, we have been working really hard here to discover new compounds to treat or at least to delay some symptoms of Wolfram syndrome. And even right now, several drugs are on discovery phase. And yeah, Anton.
I am Anton, and as Mario said, we never stop working here for Wolfram syndrome, at least as long as these rats live. And the presentation that I will speak today, or present on behalf of this house, is about the lifelong treatment with GLP1 receptor agonist, and that was liraglutide that we used for this lifelong treatment. And we used the rat model of Wolfram syndrome that was developed and characterized inside this house. So all the work was done at the University of Tartu in Estonia. And this particular experiment was sponsored by IFO Foundation, so by Lode and kind people who donate money there. First of all, I want to show about rats and try to convince you that this rat has indeed Wolfram syndrome, and then what we have done and what we have found in this rat using GLP1 receptor agonist. So there's 3 rats in this picture, and they actually are Wolfram knockout rats, so that they have Wolfram syndrome, and these rats are relatively young, so they look pretty normal. And the Wolfram gene is invalidated in these rats, so they are mutant. They have similar mutation to all the Wolfram syndrome patients. And on this slide, you see normal rats. At the age of 15 months, it's relatively old rats and male rats, and they are big. They are 1 kilo of body weight, and they look pretty happy and healthy. And the fur and everything is fine, and also the bedding is dry. So notice that. And this is how our Wolfram syndrome rats look like when they are older age. So you see that the bedding is wet because they have diabetes, so there's polyuria, and they produce a lot of urine and drink a lot. And they don't groom themselves anymore, so they become dirty in a way, and also they lose weight because of diabetes, so that they don't look happy or healthy at all. And this is how Wolfram syndrome looks like in the rats. And if you compare eyes of these older rats of normal rats and of these Wolfram rats, you see that they have cataracts. So that this is another feature we see in these rats, that vision and diabetes and hearing loss and everything. So in general, this is published about these rats. If we line up all the symptoms of Wolfram syndrome, then this rat has probably all of them. So it develops diabetes, and by the age of 10 months, it has diabetes in the same, so in glucosuria and fasting hyperglycemia, and it happens by the clock. So every rat of Wolfram syndrome rats, they have diabetes with the same, they develop diabetes more or less with the same pace. And on the neurological or neuro side, they start to develop cataracts already at the age of 3 months. So it's actually before the diabetes we have seen it, but mostly it's later. And they develop markers of ER stress or endoplasmic reticulum stress in the brainstem. And they show optic nerve degeneration, but we see this histology at older age, when they are older than 1 year. And they become blind and also deaf at this age. So basically they have everything what comes with Wolfram syndrome these rats have. So they have rat form of Wolfram syndrome, I would say. And In our university or in this laboratory, we have tried many treatments with GLP1 receptor agonists. And the first treatment was with exenatide, and it was done in Wolfram syndrome mouse. And it lasted two weeks. And it showed that the exenatide or GLP1 receptor agonist was able to improve glucose intolerance in these rats or restore. Then we tried the same experiment in the rats using 7 days, 1 week exenatide. Then we switched to liraglutide and again 1 week. Then we did 5 months liraglutide treatment in the younger rats to see if it prevented development of diabetic phenotype or diabetes in these rats. And it was followed by 6 months treatment with liraglutide in older knockout rats to see if it prevents neurodegeneration. And we also have done one commercial project, which we're not supposed to speak about, with analogs of dulaglutide. And it lasted also 6 months, and it basically produced the same results as the previous results or the previous studies. And now what we speak about today is actually lifelong treatment with liraglutide, which we, as all of this was not enough, we did one more, and the aim was to treat animals from a very early age to until they die. And until the results of this experiment will be presented today. And some of these studies that were shown on previous slides are published, as this first mouse study and long study, 5 months in young rats and 5 months in older rats. And also Japanese group has done a similar study in mouse with exenatide. And we were lucky that we could publish our paper just a few weeks before that. So we were a little bit faster. But now, this graph here shows general properties of GLP1 receptor agonist or general effect in Wolfram animals, what we have seen in all of the animals or in all the studies that we have done. Already 1 week treatment with GLP1 receptor agonist improves glucose intolerance in Wolfram rats or mouse. And the experiment is done in such a way that we take 5 months old rats, and at this age they have glucose intolerance, but not yet hyperglycemia. So they are still beta cells that are left. And if those rats are treated with liraglutide, then glucose intolerance is improved. So after administration of glucose, blood sugar levels do not go that high, and they recover much faster. And if you take area under the curve here, for this curve, and plot it here, then you see that after 1 week of treatment, area under the curve is much improved compared to the before the treatment. So liraglutide always improve glucose intolerance in our model. And that we have seen many times, and it's very robust and reproducible and foolproof. Now, why did we need lifelong treatment? Was first we wanted to see what happens during lifelong treatment, because Wolfram syndrome is a chronic disease and it will stay with the patients, or this condition will stay. And therefore, if the patients are ever treated with a drug, then they will be treated for the lifetime or for the rest of the life. And so we wanted to see how safe it is and how long this effect will stay or so. So therefore, this study was initiated. And as GLP1 receptor was, in our opinion, the only promising drug, then at that time, then it was chosen here. And for this study, we used a large group of animals, about 20 to 27 per group. And the experiment was started in March 2019, but rats were born about Christmas 2018. So they were, or January 2019. So that the rats were exactly 2 months old when we started the treatment. And we ended the experiment last week of June, or first week of July. There was some animals were younger, some older, so we kept them until 17 months of age. And liraglutide was administered at a dose of 400 micrograms per kilogram every day and subcutaneously. So we injected the rats every day using the same syringes, insulin syringes, as patients do. And so the dose was always corrected to the body weight, and it was administered every day, mostly in the mornings. And as I said before, we had a rather large group of animals for this experiment, at least 20, and in some groups it was 27. So we had 4 groups, Wolfram rats and normal rats, and then those were divided in half. Half of them received saline, and half of them received liraglutide. And large group was chosen for the reason that because this experiment was expected to last very long, we were afraid that some of the animals will die because they develop cancer, or some animals do die just for unknown reason from time to time, so that we have enough of the animals at the end of the experiment. And then large group is always better, that we can compare the results in more powerful way or objective way. So, and the focus of this experiment was on the long-term efficacy, if this liraglutide is effective, and also on neuroprotection. So we were not so much really interested in diabetic phenotype, but nevertheless it was characterized rather well. And for this and also for safety. And for that we performed a lot of experiments in vivo, and that was glucose tolerance. We measured it at different ages. We measured the levels of insulin, Sept, and other hormones. We measured hearing sensitivity, again at different ages, and how it was affected by liraglutide treatment. And also visual acuity, so that visual acuity is measured by the ability of the rats to track lines that pass in front of them. And it's in a way the same as looking out of the train, and when you see that the eyes are moving with this optokinetic response, then we measured basically how big lines this rat is seeing, and the finer the line, better the vision. So it's a very interesting way of measuring the visual acuity of rats who do not tell what size of the letters they see. And we also performed MRI imaging to measure the changes in the brain volumes during the experiment. And at the end of the experiment, we collected all the samples for later histological analysis, so we can use, or this histology is on the way, so we're still performing the analysis of the tissue data. Now, this graph here shows the body weight of the rats in different treatment groups. And the upper line, it is the normal rats or wild type rats, what we call them, as they grow in up to later age. And you see here the decline of the body weight. So this was actually the reason why we stopped this experiment at 17 months, because we learned from the few rats in this group that when they start to when the decline in the body weight occurs, but it is here, then a few weeks later these rats actually die. So before they die, they for some reason drop the body weight, and therefore we finished the experiment here so that we don't lose more rats. So it was indeed lifelong experiment. We killed the rats just before they would die by themselves. And on the black line here, you see the liraglutide treated normal rats, and they are much, much lighter than wild type rats that were treated with saline. And that is generally effect of GLP1 receptor treatment, that it reduces the body weight during the first week already. So 1 week of treatment induces approximately 10% decrease of body weight, and then this body weight stays lower than in rats or animals that are treated with the vehicle or saline or control rats. And in this red line, you see the Wolfram rats that were treated with saline. So the healthy or Wolfram rats that were treated with control solution with saline. And first, they are lighter than the white rats, and second, approximately at 1 year of age, from 10 to 12 months, they start to lose weight. And we know from before that this happens because they develop diabetes here. So they elevated levels of sugar in the urine, and they start to lose weight here. And as we noticed that, and we measured that they indeed has diabetes here, we started to treat these knockout rats with insulin. So in addition to saline or liraglutide, these rats that develop hyperglycemia, or they receive also insulin to keep their blood levels of glucose in normal range. So therefore, that was, and we had to titrate the insulin dose for every rat that needed it. So that was kind of very sophisticated experiment. And in blue line, you see the knockout rats or Wolfram rats that were treated with liraglutide, and again, they're lighter than Wolfram rats that are treated with saline. So that the liraglutide induces the body weight loss for also in the Wolfram rats. But what is different here is that from 10 to 12 months of age, when Wolfram rats lose weight because of diabetes, the liraglutide group did not lose the weight. So the Wolfram rats that developed diabetes in liraglutide, they did not, in liraglutide group, they did not develop diabetes at this age of 1 year. And the second thing is that if you look here at the end of the experiment, animals from every group, they started to lose weight because probably just as this, that they were so old. And also the saline treated Wolfram rats started to lose weight, but it did not happen to liraglutide treated Wolfram rats. So these rats did not start to die just by themselves. It happens only to all of them. So liraglutide probably would keep these rats even longer than normal rats. And if you look at the fasting blood glucose levels, so we measured that at different ages, at 3, 7, 9, 10, 1 year, and 60 months, and so on. Then we see that in the black lines correspond to the normal rats, the wild-type rats, and the blood glucose levels do not change with age, or fasting blood glucose levels, they stay at basically the same range as in humans, 5, 6 millimoles. But in the Wolfram rats, approximately 10, 12 months, these blood glucose levels go up, indicating that they develop diabetes. So they develop fasting hyperglycemia, and it is much delayed in the animals, in the Wolfram rats that were treated with liraglutide. So the development of hyperglycemia was much, much delayed. And if we see at every rat in the population, what we had there, then at this late age, you see that in this knockout, or in the Wolfram rats that were treated with saline, there is a large number of rats that had hyperglycemia, and on average, the blood sugar levels was higher. But number of animals that had hyperglycemia was much, much lower in the knockout liraglutide. So, or in the Wolfram rats that were treated with liraglutide. So number of these dots here is much smaller than here. And most of the animals, they still remain normal glycemic in fact. Now, glucose intolerance, it's basically it's very similar in young animals. So before we started the experiment, we performed the glucose intolerance test, and we saw no difference here, so that they are basically the same or slightly elevated. Few rats had already glucose intolerance already at 2 months of age. But as animals get older and older, then glucose intolerance gets worse and worse. So this red line here corresponds to the rats, Wolfram rats that were treated with saline in control group. And you see that after administration of glucose, blood sugar level goes very high and it stays high. In contrast, if we take the rats that were treated with liraglutide, so the Wolfram rats that were treated with liraglutide, the blue line, the blood sugar levels do not go as high and it returns to normal faster. So it is, and it's even more evident at older age, at 1 year of age. And if you take this area under the curve for each animal, then you can see here that at 8 months of age, basically all the rats, they have increased area under the curve, and it's not so in the liraglutide treated Wolfram rats, so that half of the rats, they actually stay at the same level as the wild types, and only few of them develop glucose intolerance. And even in the 1-year-old rats, we still see at 1 year of age, we still see the rats that have the same level of glucose tolerance as the wild types or normal rats, and then half of them are developing glucose intolerance. But in contrast, all the rats that were treated with saline or the control solution or Wolfram rats, they all develop hyperglycemia or glucose intolerance. So that the diabetic phenotype is clearly, or development of diabetes is delayed by liraglutide in this experiment, what we can say with certainty. And if we plot age and this area under the curve again, then we can see that in the liraglutide treated animals, the blue lines, there are many animals that actually did not change glucose tolerance at all. So they kept the glucose tolerance at the same level as they were at 2 months of age, even when they were 12 months of age or 1 year of age. But instead, the rats that were treated with saline or with control group, most of them, they developed glucose intolerance. And if you take the average, then this is here on this inset, we see that in saline-treated Wolfram rats, glucose intolerance develops approximately twice as fast as in the liraglutide-treated Wolfram rats. And in the wild-type rats or normal rats, it stays the same. So from that, we would say that liraglutide treatment delays the progression of diabetes by a factor of 2 or perhaps 3 in the rats. How it happens in human or how it translates to human, it should be investigated further somehow, but already in the patient. And again, the C-peptides, insulin, and glucagon levels, they measured in blood of rats at different ages when we performed glucose tolerance test. And at 2 months of age, everything is pretty much normal, so that there is no big differences between Wolfram rats and normal rats. They still secrete C-peptides, so therefore they secrete insulin, and it was also seen here that although less, but they still do secrete insulin when they are 2 months of age, and there is no difference, and that was where liraglutide treatment started. So at the beginning of the experiment, all our rats were similar, so that Wolfram rats who received the saline or the control solution, they were exactly the same as Wolfram rats that later received liraglutide. So at the starting of experiments, they were exactly similar. And if they were different at the end of the experiment, it was because of liraglutide, not because they were different at the beginning. That is very important here. That's why this experiment was done. And now, if we take the same rats at 8 months of age, then we see that after administration of glucose, the serum C-peptide levels as indicators of insulin secretion is elevated in the wild-type animals, and I'm sorry for that. And there is no elevation of C-peptide in the Wolfram rats that were receiving saline solution. But in liraglutide group, there was although C-peptide levels were lower than in the wild-type rats, there was still remaining some activation by glucose administration. So there was still glucose, the beta cells or pancreas, this rat is still responsive to glucose administration, I would say. And the same was seen in the insulin secretion. So that if after the glucose administration, the normal rats, they secrete insulin as they should, then this secretion is lost in the Wolfram rats that were receiving saline. But it is still, something is left, or this glucose stimulated insulin secretion, something of it is left in the in the Wolfram rats that were treated with liraglutide. And exactly opposite is with glucagon levels that indicates is the marker of diabetes. More glucagon, harder the diabetes. It's that glucagon levels are lower in the Wolfram rats that were treated with liraglutide, approximately to the same level as the normal rats. So there is no increase in glucagon levels. And basically the same picture stays when rats were 12 months old, so that glucagon levels were higher in the Wolfram rats treated with saline, but somewhat less so in the knockout rats treated with liraglutide. So liraglutide certainly somewhat delays progression of diabetes, and as I said before, probably by a factor of 2. Now, we also measured urine glucose levels in the fasted animals. So that animals were fasted for 3 hours, and they were not any experiment we have done. We did always after 24 hours after the injection of liraglutide. So there was kind of washout period. So we never did the experiment immediately after the administration of the drug. And if you look at the Wolfram rats that are treated with saline at 12 months of age, we see that there is large number of rats that display very heavy glucosuria. It's this logarithmic scale here. So actually, at this point, it's sky-high level of glucose in the urine. But there's much lower number of such animals in animals that were treated with liraglutide, in the Wolfram rats that were treated with liraglutide. So it's only 3 rats here or 4 rats that show some signs of glucosuria, but it's twice or thrice number that in the saline treated Wolfram rats. So it again goes in line with all the previous things that the diabetes is, or progression of diabetes is delayed by liraglutide in Wolfram rats. And we injected insulin to the rat, or administered insulin to the rats in order to keep their normal glycemic. Otherwise, you would see the artifacts based by the hyperglycemia. So we have to keep the levels of blood glucose in normal range by administering insulin. And this is also exactly as the patients do. And you see that number of animals that receive insulin is 22 out of 25 for saline group of Wolfram rats. But it's only 10 out of 21 for liraglutide group of Wolfram rats again. And also the average level of insulin is much lower, so that if you see the level of units per day, what rats got, it's somewhat lower in the liraglutide group than it is in the saline group for Wolfram rats. So even if we had to treat some rats from the liraglutide group with insulin, the level of this insulin or amount of insulin is still lower. So liraglutide is again, it goes so in line with the previous result that liraglutide is protective against development of diabetic phenotype, or at least delays it. Now for the most interesting part is about visual acuity and visual system and or sensory systems in general. And we measured the optokinetic response as which shows how well the rats see. And the bigger the number here, the better they see. And in black lines, you see the wild-type rats or normal rats, and the visual actually declines with age somewhat, but not that dramatically. And in the red line is Wolfram knockout rats that were treated with saline. So this is how Wolfram syndrome progresses in the visual phenotype of these rats. They lose the vision. But this visual loss was totally prevented by liraglutide treatment in the rats. So that Wolfram rats that were treated with liraglutide, they actually see exactly the same as normal rats. And that is very unexpected and not so bad finding. Now we also measured the intraocular pressure And for some reason, it is lower in the Wolfram rats than it is in the normal rats, and liraglutide did not have any effect on the intraocular pressure. So if decline here is happening for some reason, it's certainly not for the intraocular pressure. And we also evaluated the severity of cataracts at 1 month of age and or 1 year of age, and also at 17 months. And there is some weak sign or mild cataracts present even in the wild-type rats. It's a relatively old animal, so some of them develop cataracts, but the scale severity of cataracts goes up to 5. So it is there are some mild sign of cataracts. But in the Wolfram rats that were treated with saline, this cataract score is much higher, so the severity of cataract is much worse. And it was lower in the liraglutide treated animals, and it is even more prominent at 17 months of age, when severity of cataracts in the saline treated animals was much elevated, but it stayed the same as white-type levels or normal rats in the liraglutide treated animals. So liraglutide treatment prevented development of cataract in Wolfram rats. And if you break down all the rats, each point corresponds here for very individual rats, then we see that and the line here is the average of the wild-type rat scale at probably it was at 2 months of age or before. So we see that in the better eye, even on the better eye, animals in the Wolfram rats that saline, they show decreased visual acuity, so they see not as well. The visual acuity is lost in them. But even worse or more so for the worse eye, so that Wolfram rats, they lose their ability to see, but it was prevented by the liraglutide treatment, so that in liraglutide treated rats, the visual acuity is basically the same as in the wild-type rats or in the normal rats. And this picture gets even worse with age, so that 3 months later or 4 months later, for 1-year-old rats, we see that this visual acuity is lost even more, but it still stays the same in majority of the Wolfram rats that were treated with liraglutide. So that so liraglutide seems to prevent visual loss or loss of visual acuity in Wolfram rats. That is kind of certain. And again, the same data. If you see the normal rats, either group, normal rats treated with saline or liraglutide, they show some decrease in visual acuity with age. At 17 months old, 17 months old animals do not see as good as 8 months old animals, but level of vision or visual acuity is more or less the same in the Wolfram rats that were treated with liraglutide, but Wolfram rats treated with saline, they show dramatic decrease in visual acuity at older age, and this is prevented by liraglutide treatment. Now, our Wolfram rats are deaf, and that is evident from approximately at older age. So at 1 year of age, at 12 months, they are certainly deaf, and that is visible in the graph here. So again, the black lines, they correspond to the normal rats, and this threshold corresponds to the hearing sensitivity at particular frequency. And higher the value or higher this point is, better the rat hear. And sorry for that. And again, you can see that wild-type rats, they hear very well from frequency of 2 to 8 kilohertz. And young knockout rats, they hear approximately the same as the wild types. But the old knockout rats that are older than 1 year, they lose the ability to hear frequencies of 2 to 4 kilohertz. So they do not hear this noise here at this range of frequencies. And this is evidenced by this line that it goes lower than line here. So they lose this frequency. But young animals, even knockouts, they hear perfectly well at those frequencies. And now the same graphs were done at different ages, 2 months, 6 months, 11 months, 17 months. And what we see here is that at 2 months, the rats were indistinguishable, so that Wolfram rats and normal wild-type rats, they hear exactly similarly at these frequencies, where hearing disappears later. And when they are half year of age, 6 months of age, you can see that knockout animals treated with saline, the red line, they lose these middle frequencies here, and it is somewhat prevented by liraglutide loss. But as the animal grows older, at 1 year of age or 11 months of age, these lines again come together. So there is no difference between liraglutide and saline-treated Wolfram rats, and it is the same at 17 months. And based on that, we can say that liraglutide maybe delays hearing loss, or how fast hearing loss is developing at 6 months of age, but nevertheless, the hearing loss is lost when the animal is older. So if anything, lira might delay, but certainly do not prevent hearing loss in the rats. How it is in humans, we do not know, but that is one thing worth to consider when patients are treated with liraglutide. So although liraglutide seems to be wonderful for vision loss or preventing visual loss in rats, it does not do anything for hearing loss. And we measured also MRI imaging in the brainstem, or probably another brain structures will be analyzed as well, but it is a lot of work because we have close to 100 animals in this experiment, or we had, and it is a huge amount of work to analyze those MRI imaging. But brainstem is analyzed now, and what seems to happen is that the brainstem volume is not affected by the treatment, but extraparenchymal area, or the area around the brain and between the skull, this seems to be increased in the saline-treated rats, and this increase is prevented by the liraglutide treatment, and that is evidenced here. So that based on that, on our previous experiments, we would see that liraglutide somewhat prevents development of brain loss at the level of the brainstem as well, so that it is neuroprotective in the brainstem. And in addition, we would say that from our experience, we have done hundreds and hundreds of rats with liraglutide, and we never seen anything bad happens to rats that were receiving liraglutide, so that it is safe in the rats, in Wolfram rats. And in this particular experiment, we have lost few rats to cancer. And this strain of the rats that we used for this experiment is probably lovely. It is susceptible to cancer. It's like the same as with some dogs, that some dogs develop one disease or the other. This particular rat breed, it develops cancer. It is normal. It is drawback of this line. And we lost about 7 rats out of 97 to cancer, and most of them, or actually all of them, were in the wild-type group. So it's not in the Wolfram group. So the results of our experiment were not confounded by cancer or somehow. And liraglutide did not induce increased frequency of cancers. And two rats in the liraglutide group had hypoincidence at the end of experiments when they were old, and that's probably just because it's very hard to keep track of all the animals. We had many animals, and we treated them also with insulin, and so it was unfortunate, but it could happen, and that should be monitored also in patients. So incidents of hypoincidence, they can happen, and they did happen in rats. And in summary, we would say that liraglutide is safe in Wolfram rats, and it was safe in mouse models, or a short experiment that was done before. And liraglutide seems to delay the progression of diabetes by a factor of 2 or 3 in the rats. We do not know how it happens in humans or human patients. And 50% of liraglutide treated rats did not develop diabetes at all. So there was clear separation that some of the animals they responded to liraglutide better than others, and we had large groups, so we could see these differences. And liraglutide has basically no effect on the hearing loss, at least as long as rats are concerned, or it did not affect the decline of hearing in the rats. Liraglutide prevented loss of vision during 17 months treatment in rats. We could not treat the rats longer, so we would not know what happens in 3 or 4 years in rats. Maybe the visual would still go down, but we cannot do that in the rat, because rats do not live that long. So we don't know if it is if liraglutide prevented visual loss forever, or it only delays as it is in diabetes, but that is something what should be studied in clinical trials in human patients. And liraglutide prevented the increase of extraparenchymal space at the level of the brainstem, and therefore it is neuroprotective, and neuroprotection was also more detailedly evaluated in older rats in a study that is already published. So liraglutide certainly does not do harm, and it is, I think, beneficial for Wolfram patients. And all this experiment was done in this wonderful house. It is probably specially built for Wolfram rats, and so Wolfram rats live in this house. And it's a rat clinic in a way, and very well equipped. And Mario Plas is head of this animal center and ran it. And then our group was, including me, we have wonderful students, Kadri Sepa, who analyze MRI images, Rin Reimets, who do all the ELISA works and PCRs and so on, and Marko Pastak is an eye doctor from Tartu University Hospital. Thomas Jagomäe is a fantastic expert in histology, and Kaia Grete Kuker is our new student who is excellent in handling the rats. And if you want to contact this, then you should write to Mario Plas, and you see the email there at the bottom of this page. And we want to thank also our sponsor. It was main sponsor for this study was iHope Foundation together with Lode. And on this image here, you see actually Lode's son, Victor, and who is also receiving liraglutide, or was first patient to receive liraglutide. And he's actually holding the very Wolfram rat who also is receiving liraglutide from the same experiment. So it's a human Wolfram patient holding Wolfram rat, and both of them are treated with liraglutide. So it's this picture has a deep meaning, and we're very thankful for that. And what this study is in part also supported by the Estonian Research Council, and Novo Nordisk was kind enough to provide liraglutide for this experiment, that it was worth of tens of thousands of euros. So it was very, even the amount of liraglutide that was needed for this experiment, it was extraordinary. And it was all done at the University of Tartu, for which we also very grateful. So thank you.
Tracy, am I on mute?
Yeah.
Okay. Can I just say thank you on behalf of everybody? That was a fantastic presentation, and absolutely probably the most detailed and thorough set of experiments of a trial in mice that I think we've seen so far, especially in Wolfram. So I can see that this is masses of hard work on all of your team as well. And thank you so much for sharing this all with us. It's absolutely fantastic. There is a question in the chat, or there's a couple of questions in the chat box. The first question, perhaps if I can have really, which is from a parent of someone with Wolfram, saying thank you for this very positive information. Do your experiments show any improvement of damage already experienced in the rats? or do the effects of liraglutide work by slowing down the continuation of the worsening of the symptoms?
That, if you can have my slides to the back or also, then
Let me, sorry, I've stopped you sharing. You should
Yeah.
be able to reshare.
yeah, this one. Ah.
Share screen.
So if you look at this graph, then it certainly improves already damage that is already there. Because you see, it is 5 months old rats that are glucose intolerant. And if we treat them with liraglutide for just 1 week, we already see that they are glucose tolerant. So it restores the function of beta cells that are already there. And degeneration in general, or neurodegeneration, probably has a few steps. So that cells, first, they are normal. As in Wolfram rats, we see that at 2 months, they're perfectly healthy. And then cells are non-functional. And only later the cells die. And if the cells are non-functional, then liraglutide will probably save them or bring back. That is, I would interpret this picture as that.
That's great, thank you. And I think Loda says on here as well, as an answer, Victor started when he was 9 years old. He had diabetes and vision loss, and he's been on liraglutide for 2 years now, which I guess has helped as well. Following on from that, can I perhaps ask you as well, in the data that you showed, it looks like liraglutide has an effect on increasing the rat knockouts insulin production, but not by as much as you'd expect.
No.
Because of the improvement. So what other mechanisms do you think are going on to improve the diabetes? It's not just the endogenous insulin, is it?
That Mara maybe knows better, but you mean this graph here?
Yeah.
So first of all, we take the blood samples. It's kind of our handwriting that we measure we take the blood samples at time point 0, just before injection of glucose. And then we take the next sample at time point 30 minutes. And maybe the insulin secretion happens in between. So you see, it's a relatively late time point when we take the blood samples. And also, if you look at the glucose intolerance point, we don't take this 15 or 5 minutes point. Maybe it happens already there. We don't know. But it just happens so that we do this experiment this way. It's more for logistics than for science in a way.
Understand. Do you think part of the improvement might be because of reduced food intake, reduced appetite, direct effects of GLP1, other things as well?
Food intake, if I remember correctly, didn't really change. So food intake was the same, and they are lighter in a way. But we are again we inject glucose per body weight, so it's the same.
I just want to comment that this the level of C-peptide is much more better, let's say, biomarker for diabetes, because it shows how much insulin have been released during 30 minutes of period, because the half-life of C-peptide is really long.
Sure. Okay, thank you. There are some more questions from participants on here. I've got one here. On the slide that says supportive treatment with insulin, I wasn't clear if this was given to all rats or perhaps just those with blood glucose incidence.
Yes, it was given to only those rats who show hyperglycemia, so that we titrated the insulin amount to keep them more or less okay, and we gave long-lasting insulin, so that we injected it twice a day, and we tried to keep them more or less level. And if you see this graph, it actually, you see zero here. So even in the saline treated rats, we still had 4 rats who did not receive any insulin. But in the liraglutide treated rats, we had many rats who did not receive any insulin.
Okay.
So it was individually titrated.
And at the age of 17 months, there was only 2 left in saline group, I think.
Yeah, so it is. I think this graph is 1 month before the end of experiment, so it's slightly changed, but basically there.
Sure. Thank you. Okay, then there's another question from a delegate on here. What about the timing for the start of liraglutide in the knockout rats? So
We started at 2 months.
At 2 months.
Yeah, but that was. It's again. We probably could start a few weeks earlier, but we cannot start from beginning. So it is one week coming. And at 2 months, again, if you look at the glucose tolerance, it's they're basically indistinguishable from the wild types.
Sure.
So they're perfectly healthy. It's certainly before they would come to doctor if they come to themselves.
Sure. Okay. That's fantastic. Are we all right for time, Tracy? Are we okay at the moment?
Yeah, we've got about 5 minutes.
Oh, okay. Fine. I'm going to ask just another question at the moment of my own, and then I'll go on to this other one. I know the dose of liraglutide you'd used on a microgram per kilogram basis is quite a lot higher than is used in humans. Do you think that would be a problem for going into clinical trials, or is that quite common in rat studies to use much higher doses?
Well, that's what we found, and we did all our study with the same dose. So in a way, all our studies are comparable for that reason. Yeah. But also, we didn't invent this dose; it was taken from the literature. So it was we didn't optimize ourselves, and I don't know. It seems to be safe and it seems to be effective. So, but rats they have much faster metabolism. So for humans, for some drugs, it's up to a factor of 10 or something like that. So it's.
I've just lost the next question from somebody, but somebody from Tammy here just said, thank you very much for all of your hard work. I think the question was, when can we start giving liraglutide for our patients? And
right now.
Is it used in humans? Right.
Yeah, right now. So.
I should qualify the second part of that. Liraglutide is licensed for use in humans for the treatment of type 2 diabetes. In adults, and it's used for that purpose in children as well. There are some parts of the world where liraglutide can be given for other conditions, such as Wolfram syndrome, but only on the approval of the local doctor, and it's not licensed for that use. And in order to license it for the use in Wolfram, we have to do these rat studies in humans.
Yeah.
Similar anyway.
But it's a good template for you.
Absolutely, very good template. Very good template. That's why I asked about the dose actually. And if I may just ask another couple of questions. You mentioned that some of the rats had cancer. We know from the safety studies that liraglutide can cause thyroid cancer. Was it thyroid cancer for this, or is it different cancers?
These rats, they mostly have pituitary cancer actually.
Okay, pituitary.
And some of us, they had subcutaneous, and we are not specialists in that, but under the skin they had some kind of growing something, and the 2 rats they actually had lung cancer, but all of them were wild types.
Okay.
And we were afraid that liraglutide would increase the frequency of cancer, but they did not.
Sure.
And the funny thing then.
Sure.
Rats, they probably have slightly lower incidence of cancers, but I don't know how it is in patients.
Okay. Okay. So that's interesting. It's different anyway.
So but I would not worry that much about cancer. But if you go for a human study, then maybe you can see this graph for the dose.
I think the reassuring thing for people, I think, that is in a human study, people would be looking out very carefully to make sure that the cancers wasn't going to be a problem. So
but also for the dose, I think you should titrate the dose that in 2 weeks there is either a decrease in the insulin administration or improvement of glucose tolerance.
Yeah.
So that then you know that it is effective.
Yeah.
Okay. In the other hand, we have tested this exenatide as well. And the dose 1 up to 10 micrograms per kilogram works similar. So it's
okay.
Really low doses are also working.
Just concentrate where the time is coming to an end. There is a question here from Yukio Tanazawa here as well. Do you have islet histology of the rat treated with liraglutide?
From our previous experiments, we have done that, and that was in this published paper.
Yeah.
In this one, preventive treatment, and in these rats, we think that there's not much point of, well, there could actually be, yeah, but diabetes was not our primary interest in a way. It was brain for this long experiment.
Okay.
And but the functional study says that diabetes is still much better. So we would expect the same with histology as in this paper.
And I'm going to ask one more question. It was good to see that the vision function improved in these rats,
Yes.
and it looked like related to cataracts. Most patients with Wolfram may not have cataracts, but optic atrophy. Was there any evidence of liraglutide on optic atrophy?
These optic nerves are right now in the freezer, and hopefully one day there will be electron microscopy done on them so that we would know better.
Okay.
And but that is something again in our human study or in the eventual human study. Then one should evaluate how long. This study lasted 17 months,
Yeah.
so we wouldn't know if 17 years will do the same. But in people that would be evaluated. So.
Sure. There are no more questions on here, so can I just say thank you very much. It's been a fantastic presentation. It's truly excellent science, and it's the best. It's got to be the best animal study in Wolfram, I think, that's been completed so far. So thank you very much on behalf of all of us here, and I'll hand you back to Tracy. Yeah. Okay.
Yep, I'd just like to reiterate what Tim has said. Thank you very much. It's fantastic to hear about the research that's going on in other countries around the world, and to give our families an idea of the other research, and that it isn't just here and in America where research is happening, that there are more scientists, doctors, researchers looking into this condition that is affecting our loved ones, our children and everything. So thank you very much for the work that you're doing, and please keep up with the fantastic work, and we look forward to hearing more positive results in the future. So once again, thank you very much for taking the time out and giving us